In this video, we will be talking about the discriminant and its graph. Given a quadratic equation, ax squared plus bx plus c is equal to 0, we know that the discriminant delta is equal to b squared minus 4ac. We use discriminant to determine the nature of the roots. Does the quadratic equation have one solution or two solutions? Are the roots real or is it complex? These roots correspond to zeros on the graph. So delta, the discriminant, tells us the relationship between the function and the x-axis. Let's find the discriminant on each case. We have y is equal to x squared minus 2x plus 3. Discriminant is equal to b squared, so that's negative 2 squared, 4 minus 4 times 1 times 3. So discriminant comes out to be 4 minus 12. Therefore, discriminant is equal to negative 8. We know when discriminant is less than 0, this has a complex root. In other words, it has no real solutions. When we graph this onto the calculator, we get a graph that looks like this. Obviously, when x is equal to 0, the whole thing goes to 0, so you're left with 3. So intercept is at 3. And we have the vertex not touching the x-axis. So we say this as it does not cross x-axis. For the second problem, we have y is equal to x squared minus 2x plus 1. Discriminant in this case is equal to b squared, again 4, minus 4ac. So that's just 1. So we know that discriminant is equal to 0. When discriminant is equal to 0, we know it has a repeated root. Graphing this onto the calculator, we know that y-intercept is at 1 because when you plug in x equal to 0, that goes to 0 and we have a y-intercept of 1. And it's actually going to touch the x-axis at 1. We say this as touching or tangent to x-axis. Lastly, we have y is equal to x squared minus 2x minus 3. Discriminant is equal to 4 minus 4ac. 4 minus minus times minus times minus, positive, and 12. So we know that the discriminant in this case is 16, which is greater than 0. So it must have two distinct real roots. When we graph this onto a calculator, again, it's going to have a y-intercept at negative 3 because when x is equal to 0, the whole thing goes to 0, you're left with negative 3. Since a is positive 1, we know it's concaved up. So the graph looks like this, and we know it's crossing the x-axis twice. So we say this as it cuts the x-axis twice. So do you see the relationship between the x-axis and the nature of the roots? If it's complex, if the delta is less than 0, it's going to have a case where it's not crossing the x-axis. If the delta is equal to 0, it'll be tangent or it'll be touching the x-axis. if delta is greater than 0, it will cut the x-axis twice. Here is a quick summary of what we just did. Given a quadratic equation, y is equal to ax squared plus bx plus c, we know that the discriminant is equal to b squared minus 4ac. If the discriminant is equal to 0, it's going to be the case where the graph is touching the x-axis. Touching. Whoops, that does not look like it's touching. Right there. If the discriminant is greater than 0, it cuts the x-axis twice. So that means the graph is going to pass through the x-axis twice. If the discriminant is less than 0, that means it's floating either above the x-axis, or you could also have a case where it's going to be below the x-axis. There are two vocabularies you need to know in order to do homework. One is positive definite and the other one is negative definite. Positive definite is when ax squared plus bx plus c is greater than 0. That means all y values on this graph is greater than 0. So all y values must be positive. So it's natural that the graph must be concaved up above the x-axis. Since it's greater than 0 and not equal to, it must have a discriminant that's less than 0, and a greater than 0, that's again concaved up. For a negative definite, it means ax squared plus bx plus c is less than 0. So the y value must be always below the y-axis. So all of the values are going to be negative. In that case, it also makes sense that the discriminant must be less than 0, and also that it must be concaved down. So is it a positive or negative definite? We have y is equal to x squared plus 3x plus 4. Let's find the discriminant. Discriminant is equal to b squared, so 9, minus 4ac, 1 times 4. So we have 9 minus 16, which resulted in negative 7. So discriminant is less than 0. In order for it to be a positive definite, it must have a concaved up. In this case, we have a value of 1, which means a is greater than 0. So we can say this problem is a positive definite. Another question is y is equal to negative 2x squared plus 5x plus 1. Again, the discriminant is equal to b squared, 25, minus 4ac. We have 25 plus 8, which resulted in positive 33. We have a discriminant that is greater than 0. So this discriminant greater than 0 already tells us it can't be neither, because discriminant greater than 0 means it cuts the x-axis twice. In this case, our a is negative 2, so we know that a must be concaved down. So we'll have something that looks like this. In this case, it's neither positive or negative definite.